Hello everyone. Now let's see where I am going to solve this complex problem. This is a complex problem of this unit. Now see how to find shear force and bending moment in this problem. Let's see. First we have to find the total load. As you see clearly in diagram, there is both UDL and UVL. Both load is applied. So let's see how to solve this problem. First we have to find total load. Total load due to UDL 2 into 8 was 2 kilonewton per meter is its UDL is applied, so we will get 16 kilonewton. This is a load due to UDL, this portion only. And now again total load due to UVL. Let's see how much is this. From this 6 we get we subtract this from 6 we subtract this 2 because this 2 becomes UDL, so there is left only 4 UVL, 4 kilonewton load. So by this half from UVL formula, half into 4 into how much is total distance? 8. So we will get 16 kilonewton. Now total load on beam is total load on beam is equal to 16 plus 16 is equal to 32 kilonewton. Similarly, from equilibrium condition, RA plus RB is equal to 32 kilonewton. Consider this as first. Now taking moment about B. Let's see. By taking moment at B, see. Let's see how we'll get point A and point B. RA into how much is total distance? 8 minus this UDL. First UDL, how much is UDL? 2 into 8, and how much it rotate? It will rotate half of this length, so 8 by 4 minus the UVL is also acting downward, so it will remove this UDL will rotate anti-clockwise, so we anti-clockwise reaction we consider negative sign, so minus 1 by 2 into how much is load? 4 into how much is total distance? 8, and how much it will rotate? It will rotate 2 by 3 portion. 2 by 3 it will rotate only this portion. It means L by 3 portion only. So what is 8 by 3 equal to 0. By solving this, we will get 13.33 kilonewton. By solving all this, we will get load at RA is 13.33 kilonewton, and similarly at RB we will get 18.67 kilonewton. Now we are going to find the shear force on the beam. Let's see how to find the shear force. of this problem. First, if you want to choose a section, then let's see from the section, cutting from section. First we have to cut the section. Let's see, this is section 1 and this is UDL, UVL, A point and RA. Let's see, let the distance is x meter. By solving this, and first we have to find the UVL is acting at this point. The UVL is at this point, at this section is x, and first we have to find the UVL load of at this section. The UVL load of at this section is Wx by L. Now we have to find the shear force. Shear force at section 1 shear force at section 1 RA minus 2 into this distance, 2 is this UDL, minus half of into Wx by L into x. Take this as 1. Now at distance of x is equal to 0, this become at point there is a 0 distance, so shear force at A becomes, how much is it become? It becomes shear force at A 13.33 kilonewton. Similarly, at x is equal to 8 distance, means shear force at B point. How much we will get? 13.33 minus 2 into 8 minus 1 by 2 into 4 into 8 by 8 total length into 8. We will get minus 18.67 kilonewton. Now find at what distance from A the shear force is minimum. Hence shear force is minimum at distance of at 0 is equal to 13.33 minus 2x minus Wx square by 2 into 8. By solving this, we will get the value of x is equal to 5.57 meter from point A. At the distance of 5.75 meter from A point, we will get the minimum shear force. Now let's draw the shear force. First we have to draw the midpoint. This is the midpoint. What is the shear force at A? At point A, we will get shear force at 13.33, and at point B we will get minus 18.67. So at A point we will get 13.33 kilonewton, and at point B we will get how much? Minus 18.67 kilonewton. Now at distance of, this is point A and point B, at distance of 5.57 meter from A, let this point as B, we will get minimum at this point. So this is a parabolic type of equation. So this diagram becomes like this, in parabolic form, like this. This is not a straight line. This is positive, this is negative. This is shear force diagram. Now we have to find bending moment and see how to find the bending moment. Bending moment. If you let's first we select the section. We cut the section between A and B. This is a section between A and B. And WX by L. This section first at A, there is a reaction RA and distance is X. Now let's see how to. By this diagram, this is 2 and 2 kilonewton per meter. The UDL. Let's see bending moment at section 1 1. That is RA. This into how much distance it will move, it will rotate x distance, minus 2 into x, and this load, this by this UDL load, it will rotate x by 2 distance of this person, minus from this UVL 1 by 2 into WX by L into X, and this will rotate x by 3 portion of this beam. It means the 1 by 3 portion of this beam UVL will rotate 1 by 3 portion of this beam. But now see, consider this equation as first. Now let's see at distance of 0 meter. It means at point A, we will get the bending moment 0, because x is 0, so bending moment at A is 0, and at x is equal to 8 meter, we will get bending moment at B. Let's see, 13.33 into 8 minus 2 into 8 into 4 minus 1 by 2 into 4 into 8 by 8 into 8 into 8 by 3. By solving this, we will get 0 result. At point B also we will get 0. Then what is the maximum bending moment? So the minimum shear force rises the maximum bending moment. So at minimum shear force, there is maximum bending moment. So at distance of x is equal to 5.57 meter, we will get the maximum bending moment. Let's say this point as C, we will get 13.33 into 5.57 minus 2 into 5.57 into 5.57 by 2 minus 1 by 2 into 4 into 5.57 by 8 into 5.57 into 5.57 by 3. By solving this, we will get 28.82 kilonewton meter. At this point, we will get and this is the maximum bending moment. Now let's draw the bending moment. Let's see how to draw the bending moment diagram. First we have to draw midline, that's point A and point B. At what point it will be maximum? At point C it will be maximum. So this is a hyperbolic type of equation. So this become more curve and this type, and there is a maximum. What is the maximum value of bending moment? That is 28.82 kilonewton meter. Positive. Make this as this. So this is our bending moment diagram.